Today's topic is the amino acid. So basically, amino acid is involved in the formation of the amino protein structure. Now here, the protein is the polymer of amino acid. That means different amino acids that are joined to form the protein structure. Now here, uh, the amino is the basic group carry positive charge, and acid, that is acidic, carry negative charge. This is the structure of an amino acid here, where there is a central carbon atom is the alpha carbon, and that is surrounded by the different group. Now if this central carbon atom is surrounded by different group in its four hands, thereby it is termed as asymmetric carbon atom. Now the central carbon atom is basically having different groups that are amino group, and this amino group is the basic group, the carboxylic group is the acidic group, a hydrogen atom, and a R group. So based on this R group or side chain, there are basically 20 amino acids that are naturally found, which finally forms the different protein structure in our body. Now, due to the presence of both basic and acidic group in the amino acid structure, this particular compound is termed as amphoteric compound. And for the presence of both charge, this amino acid exists in three forms. Either it is cation, zwitterion, or anion. Now, cation is formed when the basic NH2 group is converted into NH3 plus, carry positive charge. Anion is formed when the COH, that is the carboxyl group, is become CO minus. Anion is formed. Zwitterion is formed when the compound is having both basic and acidic, that is the positive and negative charge. So therefore, at a pH where the Zwitter ion is formed, this pH is called isoelectric pH or isoelectric point. Now, the Zwitter ion carry basically total net charge 0. Why? Because the amino group, that is the positive charge, and carboxyl group having the negative charge are in equal number. So therefore, the net charge is a 0. Now, how the pi value is calculated? That is, we first understand the acid dissociation constant or the equilibrium constant K value. So what is K value? K value basically the ratio of the product divided by the substrate. Now from the from this equation, the KCOH is basically the product is a zwitterion and H plus. So therefore, and the substrate is a cation. So therefore, the KCOH equals to zwitterion into H plus divided by the monocation. Again, for the KNH3 plus, we get here, that is the monoanion and H plus are the product, and the zwitterion is the substrate here. Now these are the two equations we get. So from these two equations, we multiply them and finally get this equation. So this equation are like KCOH into KNH3 plus equal to the monoanion divided by monocation into H plus whole square. Now we know that at pi value, the cation and anion are in equal number. Therefore, these are basically cancelled out. Why? Because these are in the same number. That means the monoanion and monocation are in the same. Why? Because the net charge is 0 here. And therefore, the pi at pi value, these are cancelled out, and finally it remains as the KCOH into KNH3 plus equals to the H plus whole square. Now we take log value at both sides and finally get the log KCOH plus log KNH3 plus equals to 2 log H plus. Now we take minus value at both sides, and finally when we get the minus value, we get the pk value. And what is the pk value? Pk value is nothing but the minus logarithm of the acid dissociation constant or the equilibrium constant. So for this, pk value is the pkCOH plus the pkNH3 plus equals to the pi value. What is the pi value? And minus log H plus is the, as we know, is the value of pH. So here we replace this pH with pi and then into 2. So then we get the pi value, which is the pk value. For the general formula for pi value is the addition of the pk value for alpha COH and the pk value for alpha NH3 divided by 2. And that is for the uncharged amino acid, because these amino acid that does not carry any charge group at their side chain or at their R group. Now, for the charged amino acid like acidic amino acid and basic amino acid, they carry a extra charge at their side chain or R group. That's why the pi value for these amino acids are different. Now how? Basically, here this is an acetic amino acid that carry a COH group in their side chain R group. Now in this case, the first the charge is basically +1. That means this is a cation formation of the of this acetic amino acid, as the NH3 plus is here in case of the amino group. Now the first H plus is released from the COH and becomes the zwitterion ion formation is here, and then the second H plus ion is released from the R group. Therefore, this overall net charge is -1, and after that the H plus is removed from the NH3 plus becoming NH2, and then the net charge is -2. So here the zwitterion formation is occurred here, and this is the monocation and this is the monoanion. So previously we learned that the pi value we take the when the zwitterion ion is formed, that is the net charge is 0. So this zwitterion ion formation is occurred between the uh, pk value for COH and pk value for R group. Therefore we take the pk value COH and pk value for R group to get the pi value. We don't need this pk value for getting the pi value for acetic amino acid. Also in case of basic amino acid, here you can see this is the R group here that carry extra NH3 plus, that is a amino group at their side chain, and now the overall charge is +2. So the first H plus ion, when it removed from the COH group, alpha COH group, then the net charge is here, the that is a +1. Again, after the release of the H plus from the alpha COH, the H plus is removed from the R group, that is the NH3 plus, that remove the H plus ion becoming NH2, and here the net charge is 0, and that means this is the formation of zwitterion. And again, after the H plus removed from the RNH2, the H plus is removed from the alpha NH3 plus becoming the alpha NH2, and finally this is the monoanionic form. That means the net charge is -1. So therefore, for basic amino acid, we take the pKr value for NH3 and the pK value for alpha NH3 to get the pi value. So therefore, for a basic amino acid, the pi value equals to the pK value for our NH3 plus pK value for alpha NH3 divided by 2. So, so here is the big difference of the pi value between the acidic, basic, and for the uncharged amino acid.